Today, on Guess What I Found Out? There is a small island in the western Mediterranean that got cut off from the mainland 9,000 years ago when sea levels rose after the last glaciation, and whatever was stranded on it had two choices: adapt or die. Most things died. What survived built one of the strangest little ecosystems on Earth, centered on a lizard that has learned to do basically everything, and a flower that smells like a rotting corpse and generates its own body heat to lure flies into a trap. We're going there today, Curious George. The island is called Sa Dragonera. It sits about 200 kilometers from the Spanish mainland, battered constantly by Mediterranean wind and sea erosion. No humans live there permanently, just a lighthouse. The conditions are rough, the resources are thin, and the list of species that could actually survive long-term on a windswept rock with almost nothing to eat is very short. No mammals. Their caloric needs are 10 times higher than a similarly sized reptile. The island simply cannot feed them. That left the door open for something more efficient. The lizard is called Podarcis lifordi, and we are going to call it the black boulder bandit, because it lives on dark rocky surfaces and has developed a lifestyle that can only be described as opportunistic to the point of philosophy. Its ancestors were almost certainly insect eaters. But insects alone cannot sustain the population density that now exists on Sa Dragonera. So the black boulder bandit did what stranded animals under pressure tend to do. It became willing to eat almost anything. Plants, marine debris, dead jellyfish, which it eats without apparent concern for the stinging cells, live arthropods that wash up on the shore, scraps from seabird regurgitation, fly larvae in waterlogged driftwood, thistle pollen, navigated carefully around the spikes, sandfire flowers, where the lizard has effectively become a reptile pollinator. The black boulder bandit is not a picky eater. It is an everything eater. The behavioral mechanism that drives this is worth understanding. In any population of black boulder bandits, there are bold individuals. These are the ones that will walk up to a strange new object, investigate it, and, well, taste it. Most new things are not food. Some are. The bold individuals take the risk on behalf of the group, and the rest of the population watches and learns through imitation. This is not social behavior in any warm, fuzzy sense. It is, in fact, a distributed risk management system. The bold lizards absorb the cost of experimentation. The cautious ones harvest the information. The species as a whole adapts faster than any individual could alone. They have learned, for instance, to listen for flies. The dead horse arum lily, which we will get to in a moment, traps flies inside its flower. Black boulder bandits have figured out that a buzzing sound coming from inside a flower means protein is available. They climb in and eat the trapped flies. This is learned behavior. Somebody did it first, others watched, and now it is part of the toolkit. But the real story on this island is the relationship between the black boulder bandit and the plant it has built its life around. And that plant, well, it deserves its own introduction. The dead horse arum lily has been on the Balearic Islands for 30 million years. It predates the island isolation. It predates most of the other things alive there by an enormous margin. And it has spent those 30 million years perfecting a strategy so elaborate and cynical that it belongs in a heist film. The plant smells like a rotting corpse. Not vaguely, precisely. It produces the exact same molecular compounds released by decomposing flesh. Putrescine, cadaverine, the full suite. And it produces them in competitive quantities, meaning it can chemically outcompete an actual dead seabird or rabbit lying nearby for the attention of flies. The flies are looking for a place to lay eggs. The dead horse arum lily is telling them, chemically, that it is exactly that place. It is lying. At dusk, the spathe, the funnel-shaped structure that forms the flower, opens. The interior is designed for one-way travel. Downward-pointing hairs at the entrance let flies in, but resist exit. The walls are waxy and slippery. The inside colour grades from black at the base to a translucent ring near the top, which concentrates available light and creates a visual signal that draws the fly downward toward the reproductive organs. The fly is now inside, disoriented, and cannot get out. Then the plant feeds it. The female reproductive organ produces nectar. The fly drinks. For the next 4 to 6 hours, the fly is being kept alive and fed while the male organ above it matures. Then the male organ releases a cloud of pollen directly onto the trapped fly. The walls of the funnel gradually dry out. The hairs soften. The fly, dusted in pollen and well-fed despite the traumatic commute, walks out and goes looking for another rotting corpse smell. It finds another dead horse, arum lily. It enters. It pollinates the female organ on the way down, collects a new pollen load, and the cycle continues across hundreds of meters of island. The plant also runs its own heating system. Through metabolic thermogenesis, the same basic process that generates heat in warm-blooded animals, the dead horse arum lily raises the temperature inside the funnel up to 12 degrees Celsius above ambient. At night, when temperatures drop, the fly stays active because the flower is warm. The heat also helps volatilize the scent compounds, broadcasting the rotting corpse smell further into the dark. The plant is heating itself to smell worse, on purpose, to attract more victims. It is a remarkable piece of engineering from something that cannot think. And here is where the black boulder bandit walks back into the story. The lizard wants everything the dead horse arum lily has. The heat from the spike on cold mornings, which the lizard uses as a thermal basking platform, sometimes fighting other lizards for the spot. The trapped flies inside the funnel, which the lizard harvests. The fruits and seeds that develop after pollination, which the lizard eats. And here is the elegant part. By eating the fruits and defecating the seeds elsewhere, the black boulder bandit is doing the plant a favour. It is dispersing seeds across the island. The lizard is simultaneously robbing and farming the plant. Right, so here is your question for today, Curious George. If you had to pick one, which adaptation on this island do you think is more impressive? The black boulder bandit's distributed learning system, or the dead horse arum lily's fly trap with its own heating and light system? Drop your answer in the comments. And make the case. I want to know which one gets your vote for most absurdly over-engineered solution to a simple problem. What makes Sir Dragonera worth paying attention to is, well, what it demonstrates about what evolution does when resources are truly scarce and escape is impossible. The black boulder bandit became an omnivore because, frankly, it had to. The dead horse arum lily became a liar because deception was cheaper than actually being a rotting corpse. The two of them built a relationship that benefits both parties, sort of, in the way that a pickpocket and the person being pickpocketed have a relationship. Nothing here is friendly. Everything here is efficient. The island is small, the resources are thin, and 9,000 years of isolation have stripped away every behaviour and adaptation that did not directly contribute to survival. What is left is a set of solutions so precise and so strange that, honestly, a team of scientists had to use an endoscope to film the inside of a flower for the first time, just to understand how it actually worked. The world is full of islands like this. Some of them are literal. Some are ecological pockets in larger landscapes, isolated by altitude or temperature or, just the absence of a single resource. Every one of them is running the same experiment. What happens to life when the conditions get hard enough and there is nowhere else to go? Sir Dragonera answered that question with a lizard that eats dead jellyfish and a flower that generates body heat to smell like death. Not bad for a windswept rock 200 kilometers from anywhere. If you know a wild fact about island evolution, the dead horse arum lily, or any other Mediterranean endemic species that most people have never heard, drop it in the comments. Some of the best ones end up shaping future episodes, You've been watching Guess What I Found Out, the channel that finds the strange experiments evolution has been running while nobody was watching. If this one earned it, subscribe and hit the bell. New episodes come regularly, and the next one is already stranger than you'd expect. See you there, Curious George.